Hello friends, in this video we are going to solve a few practice sums based on the isosceles triangle properties theorem we discussed in our last video. Let's do the first sum. In an isosceles triangle ABC with AB is equal to AC, the bisectors of angle B and C intersect each other at point O. Join O with A and show that AO bisects angle A. Let's draw the diagram first so that we understand this better. Triangle ABC, which is an isosceles triangle where AB is equal to AC, and we have two angle bisectors BO and OC, and they intersect in point O. So we know that this is equal to this angle is equal to this angle also equal. Now we want to show that these two triangles are congruent so that then AO will bisect angles. To proceed further, we will first draw a perpendicular from point O on side BC. So we have drawn OD, which is perpendicular to side BC. So let's write it. This is by construction. We know angle OBD is equal to angle OCD. Why? Because angle ABD is equal to ACD. Isosceles triangle, their base angles are equal, and OBD and OCD are half of them, and hence OBD and OCD are equal. This is given. Now from 1, 2 and 3 we can see that angle OBD is equal to angle OCD. This angle equal to this angle, this equal to this. That means the third angle also has to be equal using the angle sum property. And we know OD is common. So we know this angle equal, this is common, and this angle equal. And therefore these two triangles are congruent. Now, since these two triangles are congruent, their corresponding parts are going to be equal. So OB is going to be equal to OC. So we have proved OB is equal to OC, and now we are going to shift our attention to triangle AOB and triangle AOC. For that, I'm going to erase this, and I'm going to only write what is required, which is OB is equal to OC. I'm just writing OB is equal to OC, which we have proved using CPCT. Okay. Now in triangle AOB, we know OB and OC are angle bisectors. That's why angle ABO is half of ABC and angle ACO is half of ACB. And we know ABC and ACB are equal because those are base angles of isosceles triangle. And therefore angle ABO is equal to angle ACO. And we also know AB is equal to AC. Let me call this as 5, this is 6 and 7. So from 5, 6, 7, OB equal to OC, ABO equal to ACO, and AB equal to AC. Side, angle, side. These two triangles are congruent. And once these two triangles are congruent, we know corresponding parts are equal. This angle is going to be equal to this angle. And these two angles are equal. That means OA is a bisector of angle A. That is what we wanted to prove. Let's go to the next sum. In triangle ABC, AD is perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB is equal to AC. So we have to prove AB is equal to AC. Now what is given? Given is this is perpendicular bisector, which means this is going to be equal to this and this is both 90 degrees. Okay, so let's use that and prove these two triangles are congruent. BD is equal to CD. AD is perpendicular bisector. That means D is a midpoint. So BD is equal to CD. AD is perpendicular bisector. Perpendicular means 90 degrees. That means these two angles are going to be 90. So that's given. Third, AD equal to AD, common. And so side, angle, side. Using side angle side congruence, we can say that these two triangles are congruent. Triangles are congruent, that means the corresponding parts are going to be equal. AB is equal to AC, that's what we were set to prove. And that means triangle ABC is an isosceles triangle where AB is equal to AC. Let's move on to the next sum. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB respectively. Show that these altitudes are equal. So we have to show that CF is equal to BE. Now let's focus our attention on the triangles ABE and CFA. And in those triangles, we have seen that these two angles are equal. That means this is also 90 degree. We also know that this side is equal to this side. And angle A is common. So I have two angles equal, one side equal. AAS. We can convert AAS into ASA by finding the third angle. We know when the two angles of one triangle are equal to the two angles of other triangle, the third angle also is going to be equal using the angle sum property. So let's write that. These two angles are equal, therefore the third angle is going to be equal. And we also know that AB is equal to AC. So that means now we have found that this angle is equal to this angle. Angle, side, angle. Using angle, side, angle, we can say that these two triangles are congruent. Triangles are congruent, that means their corresponding parts are going to be equal, and that gives me CF is equal to BE, and that's what we were set to prove.
I am sure you have liked the video. Hit the like button and leave your views in the comments section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the QTube app at the link provided in the video description. Till we meet again, goodbye.